What is an angular velocity of a two-pole generator? In a two-pole generator, one cycle of voltage is completed in one rotation. 50 cycles are completed in 50 rotations. Hence, angular velocity is equal to 50 rps or 3000 rpm. Angular velocity can also be obtained by using n equals to 120 f by p, where n is angular velocity in rpm, f is frequency of supply voltage, and p is number of poles. Capacitive load increases or decreases terminal voltage. Maximum EMF is induced in the conductors when poles are facing conductors. Since capacitive current leads voltage by 90 degrees, maximum current is induced in conductors when poles are behind by 90 degrees. Armature flux aids mean flux and resultant flux increases. Since terminal voltage is proportional to resultant flux, it increases. Do electrons move through the capacitor? Insulation of an electrical machine is a capacitor having metals on both sides. There is copper conductor on one side and iron core on the other side. When polarity of AC source is as shown, electrons move to the right side of a capacitor. When polarity changes, electrons move to the other side of a capacitor. Thus, in case of a capacitor, electrons flow but not through the capacitor. Hysteresis loss is proportional to frequency or frequency square. Hysteresis loss is area under hysteresis loop. In one cycle, one loop is completed. More the frequency, more the loops. Thus, hysteresis loss is proportional to frequency. During synchronization of generator, parameters of generator are matched with grid. They are matched before synchronization or after synchronization. Parameters are matched before synchronization. At what voltage final HV test is done in medium and large electrical machines? It is done at 2 kV plus 1, where kV is a rated voltage. It is strongly recommended that this test is not repeated. How do you define short circuit ratio SCR? It is a ratio of field current required to produce rated terminal voltage and field current required to produce rated short circuit current. Pure resistive load increases or decreases terminal voltage. Let us consider top conductor. On left side, armature flux opposes main flux. On right side, armature flux aids main flux. Increase in flux on right side is less than decrease in flux on left side due to saturation. Resultant flux decreases. Since terminal voltage is proportional to resultant flux, it decreases. There is another reason for reduction of terminal voltage. Maximum EMF is induced in conductor when resultant flux and not the main flux faces conductors. The resultant flux is less than the main flux, hence terminal voltage decreases. In a flexible rotor, is it possible to do slow speed balancing? At slow speed, running speed is less than the critical speed. Central line of shaft changes as shown. In a flexible rotor, running speed is more than the critical speed. Central line of shaft changes as shown. Balancing done at slow speed is not applicable at rated speed. What is the effect of fifth harmonic? Voltage of fifth harmonic moves 5 times faster. In the case of fundamental, phase sequence is RYB. In the case of fifth harmonic, phase sequence is RBY. Phase sequence in case of fifth harmonic is opposite to that of fundamental. Hence, torque produced by fifth harmonic is opposite to that of fundamental. Thus, fifth harmonic produces retarding torque.